Hello everyone, today we're going to be covering area under a curve. So from the previous lesson, we know that the area under a curve from x equals to a to x equals to b is just the definite integral from a to b of fx. But in general, if we want to find the area between two curves, we want to take the definite integral from a to b of the upper function minus the lower function. So here we take that whatever function is on top minus whatever function is below to find the area between these two functions. Okay, let's apply this to a few scenarios. In our first example over here, this blue area under the curve is quite easy to find. We know that this is just the definite integral from a to b of fx. This only works when fx is above the x-axis. For the second part, we'll actually need a second integral because now fx is below the x-axis. This area is actually negative of the integral from b to c of fx. Why do we need to take the negative sign? This is because, right, we're kind of finding the area between this curve, y equals to 0, and this curve, where y equals to fx. And if we take this formula over here, can you see that the upper function is just y equals to 0, and the lower function is fx. So this part in the integral is just negative fx, and we can take this negative sign out. And that's why this becomes negative of the integral from b to c of fx. Now, if you actually want to try to apply this for the first part, we can see that the upper function is just fx, and the lower function is y equals to 0. And hence, this just becomes fx minus 0, which this gives you this. So a sneaky little thing you need to remember, this becomes negative when the curve is below the x-axis. And this over here is your reasoning behind it. Now over here, we are directly finding the area between these two curves, y equals to gx and y equals to fx. Over here, the upper function or the function on top is gx, and the lower function, which is the function on the bottom, is fx. We are taking the two bounds over here, if you realize, a and b, because those two are the x-coordinates where the area is bounded by. So in this case, this very simply becomes the definite integral from a to b of gx minus fx. We don't actually have to care about the x-axis because we're just finding the area between the upper function and the lower function to find this area between the two curves. For the last example, for this part, we can just simply take this to be the definite integral from a to b of gx minus fx. Again, this is because for this part, the upper function is y equals to gx, and the lower function is fx. But for the second part of the area, we realize that now the upper function is fx, and the lower function is gx. So to find this second area, this is just the definite integral from b to c, and we have b to c because that's our two bounds, of the upper function fx minus the lower function gx. In the GDC, there's actually a little special trick you can do to find the area bounded by two curves without worrying about splitting the integral into multiple parts. So this is only for the GDC. What we can do is take the integral from a to c, and then we take mod of gx minus fx. The modulus must be inside the integral for this to work, not outside the integral. And same for the first one. If you want to find this in the GDC, what we do is the definite integral from a to c of mod of fx dx. Now let's try our question. Find the area bound by the curves y equals to x squared minus 2, where x is more than or equals to 0, y equals to x, and the x-axis. So what this means is we want the area bound by this curve over here, y equals to x squared minus 2, y equals to x, and the x-axis. And you can see that the area bound by all these three curves is actually just this part over here. So how do we find this yellow area? First off, let me just note that this point is 0, 0. And if you look at this area, we actually need to split this into two parts. one part has the upper function y equals to x and the bottom function y equals to 0. For the second part of the area, we see that the upper function is still y equals to x, but now the bottom function is y equals to x squared minus 2. First of all, let's find the x-coordinate of all the blue points that I've labeled. This is because these are going to be your bounds for integration. So to find this point here, I'm going to take it when x squared minus 2 equals to 0. And this means that x would just be equals to plus minus root 2. But we're going to take x equals to root 2 because we know that x is more than or equals to 0. And the next thing I want to find is this intersection point between y equals to x and y equals to x squared minus 2. So I'm simply going to take x squared minus 2 equals to x. And if I solve this quadratic over here, I'll get x minus 2 times x plus 1 equals to 0. And again, since x has to be more than or equals to 0 for the graph of y equals to x squared minus 2, x must be equals to 2. So for this point, x equals to 2. So let's start our integration. Let's find the first part of the area, this green part over here. If you look at this is simply just the area under the curve y equals to x. And since this is above the x-axis, we can just take the definite integral of x. And the bounds are going to be here, 0 and root 2. And now for your second part of the area, which is this green section over here, your bounds are going to be root 2 to 2. Because that's the x value where the area starts and the x value of where the area ends. Now remember, we want to take the upper function minus the lower function. So the upper function in this case is y equals to x, and the lower function is x squared minus 2. So we're taking the definite integral from root 2 to 2 of x minus bracket x squared minus 2. Now let's first do our integration, and we'll sub in the bounds later. Now it's time to sub in the bounds, and this will get us 10 over 3 minus 2 over 3 root 2. Here's the summary sheet for area under curve. Thank you so much for watching.